Biomagnification is a serious environmental problem. It is the process by which certain substances become more concentrated at higher levels of the food chain. Imagine a lake with tiny algae. These algae absorb a small amount of a harmful chemical from the water. Small fish eat many algae, accumulating the chemical in their bodies. Larger fish then consume many of these smaller fish, further concentrating the chemical. At the top of the food chain, a bird of prey eats the larger fish. The bird now has a much higher concentration of the chemical in its body than the original algae. This process matters because these substances can be harmful. They can disrupt hormones, cause cancer, or damage organs. Animals at the top of the food chain are particularly vulnerable because they accumulate the highest levels of these substances. This can have devastating impacts on populations of predators like birds of prey and marine mammals. Understanding biomagnification is crucial for protecting the health of our planet. By reducing our reliance on harmful chemicals and promoting sustainable practices, we can help to mitigate this threat. It is our responsibility to be informed about the hidden dangers in our environment and to take action to protect ourselves and the natural world. Microplastics are tiny pieces of plastic less than 5 millimeters in size. They are now found throughout the world's oceans, posing a serious threat to marine life. Due to their small size, microplastics are easily ingested by marine organisms, from tiny zooplankton to large whales. As these organisms consume microplastics, the plastic particles accumulate in their bodies. When a small fish eats many zooplankton that have ingested microplastics, the plastic concentration in the fish's body increases. This process continues up the food chain, with larger predators like sharks and tuna accumulating even higher levels of microplastics. The consequences of microplastic biomagnification are still being studied. However, it is clear that these particles can have detrimental effects on marine organisms. They can block digestive tracts, leach harmful chemicals, and disrupt endocrine systems. The pervasiveness of microplastics in the ocean highlights the urgency of addressing plastic pollution at its source. Reducing our reliance on single-use plastics and improving waste management systems are crucial steps in protecting marine ecosystems. Organic pollutants such as pesticides and industrial chemicals also undergo biomagnification. These chemicals can persist in the environment for long periods and accumulate in the fatty tissues of organisms. Bird species, particularly birds of prey, are highly susceptible to the effects of biomagnification. For example, DDT, a pesticide once widely used to control insects, was found to biomagnify in bird food chains. Birds of prey at the top of the food chain, such as bald eagles and peregrine falcons, accumulated high levels of DDT in their bodies. This led to eggshell thinning, reproductive failure, and population declines in these species. While DDT has been banned in many countries, other organic pollutants, such as PFAS, continue to pose a threat. PFAS are a group of chemicals used in a variety of products, from non-stick cookware to firefighting foam. These chemicals are highly persistent in the environment and can biomagnify in food chains, potentially causing health problems in wildlife. The case of organic pollutants and bird species highlights the importance of monitoring and regulating the use of chemicals in our environment. The consequences of biomagnification extend beyond individual species and ecosystems. Human health is also at risk. People who consume contaminated seafood or game meat may be exposed to high levels of harmful substances, potentially leading to health problems. For example, mercury, a heavy metal that biomagnifies in aquatic food chains, can accumulate in the tissues of fish consumed by humans. Exposure to high levels of mercury can damage the nervous system, particularly in developing fetuses and young children. Addressing biomagnification requires a multifaceted approach. Reducing our reliance on harmful chemicals, promoting sustainable practices, and monitoring contaminant levels in the environment are all essential steps. By understanding the interconnectedness of our ecosystems and the potential consequences of our actions, we can work towards a healthier and more sustainable future for all living things.